perhaps the answer is a no. And the answer will continue remaining a no for several years to come for a multitude of reasons, depending on what you're trying to achieve or what you're trying to replace. So if you're trying to replace or simplify or speed up the activity of diagnosis of a problem with a machine, to some degree, that can be automated. But what we have seen is that the level of performance of many of these diagnostic tools, which operates based on rules or automation of the rules, the performance can be fairly poor, and the performance is about 30 to 40%, depending on which machine you're talking about, under which conditions. The second part, which is where automation or AI is being talked about, is in the area of recommendations or prescriptive analytics. And we have seen that the performance of most of the recommendation systems out there or prescriptive systems out there is less than 10%, for the simple reason that vibration data alone does not have all the information that is needed to make a useful recommendation. A lot of the information is actually in the context in which the machine is operated, the process under which the machine is operated, kinematic information related to the machine, the way the machine interacts with other components in the machine train, and so on and so forth. So, given the quality of data that we have as of today, the amount of labeled data that we have as of today, and the way vibration data is managed, because vibration data is treated as fairly critical data sets, most of the time, which means that it's not really vibration data from one plant is not necessarily used in another plant that belongs to another company. So all these regulatory aspects, in addition to the technical aspects, technical challenges, makes it extremely difficult to build even build machine learning systems or AI systems that are capable of providing high quality recommendations, which means that vibration analysts or machine experts or maintenance experts who understands the machine and the process under which they operate still play a very, very critical role in terms of deciding what is to be done with the machine, how should the machine be prioritized, how should the machine be operated. And we expect that this will continue for very many more years to come. So what we think is a more scalable approach, a more widespread approach for using AI, is to augment the vibration analyst in a way that accelerates their workflow in today's world. What do we mean by that? As we said before, vibration analysts are quite critical in the process of root cause analysis, diagnostics, and recommendations. And most of the time, a plant expects the vibration analyst to provide them with concrete recommendations in terms of which machines to focus on and what is to be done with the machines. And given that vibration analysts will continue playing a critical role going into the future as well, we believe technology is best used, or AI technology is best used, when it is used to supplement or accelerate their workflow, as I said before. So one way in which AI can support that workflow would be to enable the vibration analyst to focus on the right machines and the right time periods to focus on. Say that the vibration analyst is monitoring a fleet of thousands of machines. What are the top 50 machines that they need to focus on, and what are the time periods or what are the measurements that they need to focus on, instead of the vibration analyst randomly looking at the measurements or looking at trends in terms of values? So what are the machines and the measurements that they need to focus on? What are the most suspicious ones? So once an AI technology enables them to focus on this, then the vibration analyst can focus and spend their time doing what they are capable of doing the best. That is, performing accurate root cause analysis, diagnosis, and providing the best recommendation to the plant in terms of what is to be done.